All right, so in this tutorial, I want to cover some of the basics of baking global illumination into your scene in Unity. I am certainly not an expert pro at this, and I don't really have any interest in diving too far into it, since Unity is starting to show some previews of currently a beta version with a new way of doing the baking. So, but until that's released, we need to dive in and figure out how the system works. So I have a scene set up here. This is a model created by one of our graduate students, Lisa, and she's building basically the whole Forbidden City. So, but we're just going to start with this one block here, this one model, and I have the lighting set up as a kind of at the default base setting. So we have a directional light sitting over there, kind of positioned relatively close to where I have the sun. As I'm moving this, is changing that direction. We'll do something different here in part 2 of this tutorial. But I haven't calculated any bounce, right? So I have just this blackness over here. The other thing too, just so we get a sense of how long it takes to bake. When you're doing baking, Unity has a cache that it hides somewhere, and it tries to use that information. So as you're doing baking, you do one large one, and then you make little changes. It should get faster as it goes along because it's already done some of that work. But for the purpose of this tutorial, I went to Unity Preferences, and there's just some basics here, but the GI cache is just sitting here, and you can clean it out. So before I start this tutorial, I wanted to start fresh from the little examples I've been working up, and that cache size from this and other projects was about 10 gigs. So again, that's extra information. Once you bake it, you get your light maps out of that. That doesn't go away when you delete the cache. But this other information that Unity stores to help it do this quickly, especially when just little tiny changes are made, are stored here. So I got rid of that for now. Okay, so let's just jump in here. As a default, these would both be on. In fact, before I get there, I think it's pretty, I'm not going to cover everything here, but the model itself, we've turned the whole thing to static. We can't do light baking unless we have static objects, right, that aren't going to move in the scene. So we're good there. So I'm going to jump into the lighting, and as a default, Unity has both of these turned on, but its own documentation says basically don't do both of these at the same time. I don't understand why they would have both on as a default. So let's just turn off the baked GI. And we're just going to go with the default of the pre-computed real-time GI. Let's leave the resolution at 2, and we're going to go ahead and do a little bake. So I'm going to do this. I'm going to pause the recording. It should only take a minute or two in this light scenario, but I'll pause this and we'll come back. Okay. So the bake, I wasn't paying attention, did not take that long to do. And you can see we have nice looking lighting on the model itself. And of course the advantage of this is that as I change the lighting itself, it updates not just the let's put it back where it was. Not just the shadows themselves, but the overall bounce lighting in the scene, right, and how that's affecting the overall lighting. In fact, let's go over here to the unseen scene. So I can't see baked in the global illumination because I have a different because I'm using the real-time setup. So you can get an idea of how the different maps are being utilized. You can dive into the documentation if you want. Let's go back to shaded here, right? So we are getting some nice illumination, some bounce. It's taking light from this procedural gradient that's in the background. But there's one thing I wanted to show you. You can see this shadow here getting these kind of weird seams. It's like the light is shining through. In fact, you can see it in here as well, right? And it just has to do with how the real-time shadows are calculated. The only way I found really to fix that is if I select this object here and go into the inspector. As a default, any object is set up to cast shadows. You can turn that on or off. You can also set up two-sided. So it will consider not only the polygons that face directly towards the light, but basically it's like doing two-sided normals. So if I turn that back to on, you can see that light in essence is leaking through some of the holes because it's only considering the leading edge of these polygons, not the normals that are facing away from it. So let's go ahead and turn. In fact, let's look at this again. So click right there. Let's say two-sided. You can see it gets rid of those lines. And are there any others? Kind of here in that object. Just let's go ahead and choose this one. So two-sided. You just saw something flick on and off. So this right here, right? Wasn't really getting everything. And I don't know what the hell. Let's do the roof. Okay. So that will up the calculations, but it will make for a much better real-time shadow. Okay, let's see if it, and it fixed this. It's not perfect, but it's definitely better than it was, right? Okay, so that's the real-time lighting. The pre-computed real-time lighting. And again, if we move the light source itself, we can get something else. So the second part of this is what happens if you want to use something other than just this procedural light in the sky, right? So what I've done is I've gone into, let's click on this. We'll double click. So I have this HDR image of this very pretty cloudy sky, has sun in here. And what I want to do is use that for the lighting illumination in my scene and not this procedural one that's up here in this base, right? So this would be image-based lighting in the game engine sense. So how do we do that? So the first thing we need to do is create a material that we're basically a skybox material, and then we need to change the properties for this image so that it is mapped into a sky dome, right? So let's just right click and create a new material. Let's call that tutorial sky, right? And instead of the standard shader, we'll come down to skyboxes and let's just say cube map. In fact, if I did this before, let's see, skybox 6-sided, you can see when I create this, it's asking for the 6 little images, basically the sides of a box, right? But if I do this with the cube map, right, so I can put just one image in here if I want to do that. So if I come down to the Stormy image, and right now it's set up, so this is like the import settings for it, right? So we'll leave that at default, but the texture shape should be cube. Let's not convert it to sRGB. I want all the lighting information, the floating point, and we'll just leave it at the default rest of everything. I don't think that's going to be a problem. We'll hit apply. It will take a second, but you'll see the icon over here is going to change from just an image itself to a sphere. Okay, basically it's been cube mapped and you get a sense of how this would look. So if we go to our tutorial sky now and we put that in there, it likes that. It has exposure settings that we could use to brighten that up if we want. We'll just leave that at 1 for now. We could tint it. And let's go back to the lighting. And as a default, it says up here, default skybox. We could click here if we want, and then what did I call that? Tutorial sky, right? So let's go back here. You'll see actually is the lighting itself is going to change because of this dome that is in there, right? Just from the reflections itself. But we need to recalculate everything update it based on that new sky map. But what I want to do here is just so we can see its effect, let's go to the directional light and let's make its intensity 0. And let's go back to the map here and let's make this 1.25 maybe. And this should do it pretty quick. Let's just go ahead and rebuild that map. And so it was already there. It just needed to update just a little bit. Right? So you can see we now have the lighting provided by the sky map, or the skybox. Okay. We can change this around. Let's see, how did we have the shadow working before? I think it was coming in from over here, right? So if I go to that box, let's go to the inspector. There we go. For the skybox here, in fact, maybe I should have named that tutorial sky. Tutorial skybox. All right. I can go ahead and up the exposure if I wanted to, make it a little bit brighter. I could also rotate it. I'm going to put the sun about there, and because that's kind of where I had that directional light in here. So let's go ahead and turn that intensity back to 1, which is too much, right? Because it's kind of a cloudy sky. Where'd that go? There we go. Let's do 0.5. That seems a little bit better. Right, so we're getting a nice blend of the lighting from the sky along with the directional light simulating that localized light source right here, right? How are we doing on time? Okay, so then the last way we could consider this. So the advantage here is that I can move the light around, change the shadows in real time, and if things move, well, not if they move, but if the lighting conditions change, the global illumination will update in real time. So that's great. One of the limitations, though, is that its accuracy could be not quite as detailed, in my opinion, as the baked GI. It also has more overhead as far as what the calculations would be. Of course, we're using the lowest settings right now. And this doesn't work very well if you're going to do like mobile. You don't want to, the processor doesn't want to have to do a bunch of real-time GI calculating. You want to go ahead and use image maps. So let's go ahead and turn off the pre-computed and let's go to the baked GI. And then the other thing that you can see, all of a sudden we don't have any of that lighting taking place. We have the dome itself. We do have a light source. One thing that we didn't add before or talk about is so we have the intensities rather low. We have the bounce intensity. We can set it to soft shadows. And let's see, do I have to look at that in the inspector? Oh, and the other thing here, so this is where I forgot it. So it's a directional light and the baking type is real time, and we have some quality controls for how that real time shadow is being calculated. If we switch this to baked, we now get, all that goes away, and we get soft shadows, and we can set the baked shadow angle. So if we want soft shadows, let's just do 2.5. Well, let's just do 2. Does not take much with that directional source. Let's make this 0.65. Okay. Maybe 0.6. Okay. So what we're going to get here is, instead of the hard shadows, or relatively hard shadows, we're going to get a more diffuse shadow that's calculated. It's going to take longer to do it, but these will get softer out here. And the reason I want to do that is that's kind of what's happening in the image itself, right? The light is coming through the clouds, and the clouds are going to soften the shadow, make it more diffuse. So I'm going to set this up. Well, again, we'll do the same thing with a little pause, and let's see what happens with the bake. Let's just make sure we're here. Got everything set. I did relatively low setting here, 20 for the resolution, and I don't have ambient or final gather turned on. So let's go ahead and see what happens. I'll be back in a sec. Okay, so that took like a minute or two. And again, the baked resolution I turned down to 20, which is about half of the default there. And I don't have the other things baked into it. So you can see though, relatively nice and soft. The shadows in here are being calculated in a nice way. And if we zoom out, you get a sense of how soft the shadow itself, it gets pretty diffuse. You can see how diffuse it is here in that spot, right? So I'm gonna, what I'm gonna do is one last time is I'm gonna up the resolution and turn on some of these others and look at the quality and see what we get. So baked, let's go up to 40. Let's increase the indirect resolution, it's gonna take a bit. And we'll just leave these at the default. All right, so I'm going to pause this again and we'll see what we have here in a second. Okay, we're back, and it's not something I could really toggle back and forth, but when I updated, I noticed just a little more definition with the increased resolution in the shadow areas of the model, especially these here. Again, still very soft. There's also some nice occlusion that appeared along the edge, I guess, of the building. So all in all, I mean, I think that looks pretty nice. We have 3 light maps based on that resolution. Those light maps themselves change based on the resolution. So when we had it really low, we were just getting 1 light map. So it makes sense that we're getting better resolution in there. These secondary maps here, while I'm thinking of it, have to do with this additional information that tells processing Unity how to deal with like normal maps. So if you, I don't have time to do this now, but if you go into Unity settings and you look at in the documentation for the directional mode, non-directional simplifies things so that you do not get that little map that you saw. Directional will give you a decent quality light mapping information baked into, say, a normal map, and the directional specular will add additional maps, so it takes longer and a larger memory footprint and everything. But this will give you the best result. So if you're using lots of normal maps and you really need that detail, you'll go here. But you can also turn it to non-directional right at the very beginning to get really quick bakes. So it's not using that. And if you look in the documentation, there's an example of like a barrel, like a wooden barrel, and you can see the 3 examples and the differences between these 3 methods pretty clearly. So anyways, I'll leave it at that. Kind of a long one, but hopefully you get a basic idea. Let's recap. Use one or the other. Do not use both of these. If you're using real-time shadows in here, you might have little gaps, so turning an object to two-sided can get rid of that problem. Again, a little bit of a performance hit. And if we go back to the lighting, if we used baked GI, here's your resolution. This indirect resolution only appears when this is not on. You can see actually this was at 2 a second ago. When I make this active, it takes that value that I had from the indirect resolution and puts it here. Let's turn that back off. Ambient, final gather, we just left those at the defaults, and we didn't even really talk too much about this stuff down here. I would ignore it for now. And we also changed the skybox, and we already had a directional light in there. As a default, it doesn't have the directional light. I put it in there manually. If you don't put anything in here, Unity assumes that if you have a directional light, the brightest one should basically be the sun, right? We bumped up the ambient intensity, so how much light and information is coming from the sky dome around us. Okay, that's a long one. I hope it helps.